Okay, so here's an example of how we can use the properties of integrals to solve a problem. So let's suppose that we are given the fact that the integral from -1 to 7 of f of x dx is 5, and the integral from 3 to 7 of f of x dx is -4. Let's use those facts to find the integral from 3 to -1 of 2 f of x dx. All right, so first of all, what we want to do is we're going to use what you should be thinking when you see that one interval of the givens is a subset of the other is you should be thinking about the additivity property. So what we know, for example, is that the integral from -1 to 7 of f of x dx is equal to the integral from -1 to 3 of f of x dx plus the integral from 3 to 7 of f of x dx. And we know a few of these values. In other words, we know that this is a given is equal to 5, and this, which is also a given, is equal to -4. So we can rewrite this equation as 5 equals the integral from -1 to 3 of f of x dx plus, or sorry, I should say -4. This is a true statement, so I can add 4 to both sides and say that therefore 9 is equal to the integral from -1 to 3 of f of x dx, just by adding 4 to both sides of the equation. I can then say that the integral from 3 to -1 of f of x dx is equal to -9. That's that first property that I said really doesn't have any geometric intuition to it. Just that if you switch the order, if you switch the limits of integration, you negate the answer. So therefore, I can say that the integral from 3 to -1 of 2 f of x dx is equal to, by the constant multiple property, that's going to be 2 times -9, which is equal to -18. And that's the answer. So these types of problems are a little bit puzzle-like, but let's just do another one with slightly different facts. So suppose we're given that the integral from 1 to 10 of f of x gx, of f plus g, it rather is 15. The integral from 1 to 10 of g is 8, and the integral from 10 to 20 of f is -17. So let's find the integral from 1 to 20 of f. So what we know is that the integral from 1 to 10 of f of x plus g of x dx is equal to the integral from 1 to 10 of f of x plus the integral from 1 to 10 of g of x. That's the sum slash difference property. So let's see. So we're given that this is equal to 15, and we're also given that this is equal to 8. So we can figure out that therefore, just by solving, I don't even have to rewrite this algebraically, I can say that 15 is equal to blank plus 8. That means that this must equal 7. So now what we know by the additivity property again is that the integral from 1 to 20 of f of x dx is equal to the integral from 1 to 10 of f of x dx plus the integral from 10 to 20 of f of x dx. So that's going to equal, we already know that that is equal to 7 because we found that right here. And let's see, or sorry, that's not the one that we found, excuse me. This is the one that we found is equal to 7. And we're given already that the integral from 10 to 20 of f is -17. So that's going to be, this is equal to -17. So I have 7 plus -17, and that's just going to equal -10. So that's the answer.